Okay, good day. We are looking at determining the equation of a line. So on the grid shown, and we're going to go through a bunch of steps here and then lead us to coming up with an equation, right? So on the grid shown, plot the point 4, 1. So 4, 1 is there. How many lines pass through the point 4, 1? Well, think about it. You could have many different lines, right? So we could have, we'll try here, this line, this line, this line, whole bunch. Basically, an infinite number of them. Okay, so I'm just going to move these away right now. So, infinitely many. How many lines pass through the point 4, 1 with a slope of 3, 2? Well, now we have a specific criteria. It has to have that slope. So if it has any different slope from that, doesn't pass that information. So slope of 3, 2, remember, numerator is the rise, denominator is the run. Okay, so from this point, you always have to start with a point and then use the slope. So up 3, 1, 2, 3, to the right 2. And I always recommend filling up as much of your graph paper as you can. Notice how that only went to the right. Remember that 3 over 2 is the same as negative 3 over negative 2. That's not in lowest terms, but it's still an equivalent fraction. You could show 3 over 2 as 6 over 4, still the same slope. So if we use negative 3 over negative 2, then we're going to go down 3 to the left 2. And now we can fill up more of our grid. Okay? If you only use 2 points, the likelihood, even with a straight edge, you're going to be a little bit off by the time you extend that line out. Okay? So I've kind of skipped ahead here. How many lines? So there's just one line. Okay? Accurately draw it, which we've plotted the points. And so now I'm going to draw a line through that. Okay, use a straight edge. I'm just going to fix it up here. I'm going to put arrows on the end because this line goes on forever. There we go. All right. Okay, label the coordinates of as many points as you can. So that's why I did all of these. So negative 2, negative 8. Here's 0, negative 5. 2, negative 2. 4, 1, of course. 6, 4. 8, 7. And 10, 10. Okay. Does the line pass through the point 4, negative 11? Sorry, negative 4, negative 11. So here, looks like it might, but we don't have enough of our line shown, or sorry, enough grid paper shown there. So, not sure from graph. And that's how algebraically we're going to figure it out. So it says use the slope formula to verify your answer. So remember, slope is y2 minus y1 over x2 minus x1. So points on the same line, remember, have the same slope. So now if we're going to test out the point, negative 4, negative 11, then I'm going to test it between these 2 points here. Okay, so I'm going to go y2 minus y1 over x2 minus, x2 minus x1. And I want to make sure I get the slope of 3 over 2. So now, if I do that, I get 3 and we get 2. Sure does. Okay, so yes. All right, then Sam claims that the line passes through the point 4, 1 with a slope of 0.32 also passes through 1416. Use the slope formula to verify that claim. So same situation here. Just going to make it smaller. So remember, m is y2 minus y1 over x2 minus x1. So in this case, this is going to be my x2 and my y2, and I'll use this, x1 and y1. You can use a different point on the graph, but might as well. We don't even have to look at a graph now. So 16 minus 1 over 14 minus 4, that's going to be 15 over 10, which is 3 over 2. Now I don't like showing my work across in a horizontal line like that, but limited space, right? So that's why I'm doing it that way. Okay, the line that passes through the point, oops, let me just finish this. Yes, so verified, yes, 14, 16 is on the line. Okay, the line that passes through 4, 1 with a slope of 3 over 2 also passes through the point 20, comma y. Use the slope formula to determine the value of y. So this is what we were doing the other day. Okay, very similar here. So here we know the slope is 3 over 2. This is going to be my first point. Oops, that's y1. And this will be my second point. So x2, y2. So now 3 over 2, we know our slope. Okay, and now my y2 is actually just y, I'm finding the coordinates, minus y1 over x2 minus x1. I'm going to simplify that a little bit, that denominator, okay? You can multiply through by 16, you can multiply through, thinking back to junior high math, right? 2 times 8 is 16, okay, so same to top and bottom. That means that 24 equals y minus 1, so y equals 25. Okay, so the point would be 20, 25. Okay, if this line passes through the general point xy, use the slope formula to write an equation that relates xy to 4, 1. So now I'm going to use this is my my first point because we've been doing that all along. So x1, y1, and this will be my x2, y2. So we're going to keep it in that general form so that basically the equation of the line has to satisfy for any different x and y values that are related to each other. So we know our slope is y2 minus y1 over x2 minus x1. Then we know 3 over 2 is our slope. Our y2 is y. Our y1 is 1. Then x2 is x. x1 is 4. Okay, so we've got now an equation that relates any point, okay, on the line that passes through 4, 1 with slope 3 over 2. This, we don't leave it in this form. So that's why it says rearrange this equation so that y is isolated. So this is where the good old rational expressions come into play here. So I'm going to multiply both sides by 2 times x minus 4, the lowest common denominator. Or you can think about it as cross-multiplying if that's what you like. Okay. So then here, I will have 3 times x minus 4 equals 2 times y minus 1. I'm going to expand out. And it says isolate y. So that's going to be 3x. I'll add 2 to both sides. Then I'll divide by 2. So here I added 2 to both sides. Here I'm going to divide by 2. And so in this case, most times for equations of lines, we do separate it into 2 terms. Okay, so I divide each term by the 2 there. And we like to show y first. So y equals 3 over 2x minus 5. Okay, it's the same as if you leave 3x minus 10 over 2. But this is actually what we call slope, y-intercept, actually slope space, y-intercept 4. Okay, so if you know an x value on your line, you can substitute it into this equation and get the y value. Okay, it's kind of like those linear relation tables. Now we have an equation for it. Okay, much easier than the tables. Okay, so next part says enter this equation into your graphing calculator and verify that it's the same as what you drew. So I've entered it in. Because I had to switch computers, I don't have the newest version of the calculator, so it's a little bit older version. I can't do fractions, but I can use the dividing symbol, 3 over 2x. So remember, that doesn't mean 3 divided by 2x in the denominator. This is 3 over 2 times x minus 5. And then just you can go to Window, it's a standard, or if it's not standard, go to Zoom and 6 for standard screen. And there's your graph. Okay, if we take a look at what we graphed, looks pretty much the same. Not quite, doesn't look like it has the same slope, but remember this is a rectangular screen and we're going from -10 to +10 both ways. So the x axis is stretched out a little bit more. So if we unstretched it, it would be exactly the same slope. Okay, so then it says use the second calc value feature or the table feature to verify the coordinates of the points you labeled on your hand-drawn graph. So take a look. So we'll do it both ways. So if you go to second graph, which is table, you'll see x values given. We can change those. You could go to decimal values. This is going up by ones, which is totally fine. And so you can see when x is 0, y is -5. When x is 1, y is -3.5. We don't have it graphed, plotted, but it's part of that line there, so you can see it. When x equals 2, y is -2, so it's satisfying all of those. Another way, if you are in graph, remember if you just go to trace, well, it often goes to the y-intercept, so that tells you. Then if I decided, okay, I want to check this point here, -2, -8. So if I'm in trace and I go enter -2, the calculator knows that it's looking for an x value of -2. Enter on that and it'll give you the y value, -8. So that's a point. So that's another way of doing it. As well, another way, second trace, which is calculate, and that's what's written in your notes here, and the value feature. If you enter on value, it knows you're looking for an x value. So why don't we do 4 for x? And so we should get 1. That was our given point. Okay, so there's a variety of ways of checking your line. All right, so then it says complete the following table if the general point P, X, Y lies on each of the following lines. So we want to use the slope formula and get an equation in terms of X and Y. Okay, so the first one's done here. Description, passes through -2, 7, slope 5 over 3. Statement about the slope of PA is 5 over 3. So there's your one point, there's your other point, and that's in the slope formula. Okay, so let's do the next one. Oops, that's good. So line passes through B with slope -3 over 4. So the slope of PB is equal to -3 over 4. And then here, in this chart, it's just putting the general part first. So the y2 minus y1. So y2 minus y1 over x2 minus x1. So this is your x2, y2. Okay, that's equal to negative 3/4. So you could simplify this actually a little bit. I'm just going to squish this up, move this over, squish this up, move this over. Okay, and then, so this, if I simplify, it's going to be y plus 1 over x minus 6 equals negative 3/4. Most times we're going to multiply through to get it into slope-intercept form, but for right now, we're just leaving it like that. Line passes through C with slope 4, so the slope of PC is equal to 4. So now y minus negative 8 over x minus negative 3 equals 4. Simplify that a little bit. Y plus 8 over x plus 3 equals 4. Okay. Next one, we're given a graph. So here, what's the equation, what's the statement about the slope? Well, we need to find the slope. So we are given this point for sure. Look for another nice point. So this looks like a nice point. So from your left point to your right point, we have to go down to the right 5. So the slope of the line is negative 2 over 5. So now we need to know a point on it. So this one was given negative 2, 3. And your general point is xy. So that's going to be y minus 3 over x minus negative 2 equals negative 2/5. And again, just simplify any negatives. You don't want brackets. Okay. Now, for the line that passes through A27 with slope 5 over 3, we wrote it in that form in the chart. The equation is called the equation of the line. It is a statement that is true for every point on that line that passes through point A with slope 5 over 3. In order to find the equation of the line, we need to know two things. For sure, we need to know a point on the line and the slope of the line. Okay, sometimes we're not going to be given the slope, but we'll be given 2 points. So then we have to calculate the slope. Or like the last one in the chart, we weren't given the slope, but we were given the graph of it so we could find the slope. So in general, if the general point xy lies on the line that passes through the specific point A with slope m, we know that the slope of PA is equal to m, and the equation of the line is y minus x1, y minus y1, and x minus x1. In this case, that's what we're using. So x and y here, these are your general. That's your general point. Maybe you'll end up substituting values in, etc. Okay, and then the slope here is m. Okay, so write the equation of the line that passes through A with slope 1/4. Okay, and then we're going to rearrange it. Most times, as I said, we will. So y minus 3 over x minus negative 8 equals 1/4. And now get rid of the subtracting a negative, so that's x plus 8. And now we want to solve for y. So really you're going to multiply through by 4 times x plus y, or you can call it cross multiplying if you really want to. So those divide out, right? So you get 4 times y minus 3 equals 1 times x plus 8. Well, 1 times x plus 8 is just x plus 8. Okay, we need to isolate for y. First of all, expand out, get rid of the brackets. Add 12 to both sides, so that's going to be x plus 20. And then divide by 4. Okay, now, what so here we added 12, we divided by 4. Now, this form that's the equation, okay? But most times we solve for y and show each term separately, okay? Because we'll notice some, so you might show it like this, okay? Or you might actually show it like this, 1/4 x plus 5. Take a look. That coefficient of x, what's special about it? It's actually the slope, okay? And so that's why we split it up into 2 terms, because the coefficient of x is the slope of your line. The constant term is the y-intercept, and we'll get more into that in a little bit. Okay, there are several different forms, as I mentioned, of the equation of a line. So far you've seen 2 different forms. So that kind of long form in the slope equation. But we can rearrange it, just like we just did, into what we call the slope y-intercept form. So another way, this one can also be written in this form, okay, and this form. Okay, so the original form doesn't have a name. This form that we just talked about, okay, that's best when you're graphing. Calculator or on paper is called the slope y-intercept form. Oops, the word form is already there. Okay, this form is called the point slope form or slope point form. I always kind of mix them up. Okay, and then this form here, that's called the general form. Okay, sometimes you'll see it called standard form. Sometimes the textbooks are a little bit confused on that. We call that general form. We'll, on a test, give you the actual form, if it's standard or general, like the actual expression like this. Slope y-intercept form, you should know, okay, what that means. And then, as I said, slope point form, sometimes I call it point slope form. Remember, that's just a rearrangement of the slope formula. If I multiply through both sides by x minus x1, here, those divide out, and I get that form there, okay? So x1, y1 is a known point for all of these. M is the slope. B is a real number, okay, so here, and that represents the y-intercept. And then here, what's important in these ones is A, B, and C are integers. So say, for example, you get A, B, and C to be a fraction or a decimal. You're going to need to multiply the whole equation by a number to get rid of the fraction or the decimal, okay? So powers of 10 if they're decimals, or whatever the common denominator is. Also, the A value has to be positive, greater than 0. So we'll work at that as we go through. Okay, so a line with slope -5/3 passes through -4, 7. Determine the equation of this line in each of the 4 forms. So I'll start with I'll just use the chart, right, to go through the forms. So we'll have y minus 7 over x minus -4 equals -5/3, okay? Now, kind of easier, actually I'll just simplify those negatives. So here, okay, so now we're going to then put this in the different forms. What you might want to do right away is go to the slope point form, because really what you're going to do is get this by itself. So you're going to multiply through, so it's going to be y minus 7, and you're going to multiply through
by the denominator, right? So basically you can put brackets around these to kind of help you. Okay, so this is the original. This is your slope point form. Then from here, to get the other forms, so here, if you solve for y, you can see that before we solve for y, we'll expand out. Please come to the main office for messages, please. Thank you. Okay, and then we can solve for y by just adding 7 to both sides. Okay, and so that would be plus 21 over 3. So that's plus 1 over 3. Okay, so that's your slope y-intercept form. And then your general form, again, you decide which form you want to go from. You want to expand it out. You need x's and y's together. So from here, sometimes what I do is from the slope y-intercept form, okay, so I'm going to bring everything to one side. So I'm going to add 5/3 x, so that'll be 5/3 x. The y is already there. And then negative 1/3 equals 0. Okay, so I brought everything over. Okay, now I'm going to multiply through by the lowest common denominator, so that's 3. Both sides. Oops. So that's going to be 5x plus 3y minus 1 equals 0. And that's your general form. Okay, determine the equation of the line that passes through negative 119 and negative 513. Notice how we're not given the slope. So we need to calculate that first. Okay, so y2 minus y1 over x2 minus x1. Negative 6 over negative 4 is 3 over 2. Okay, now your call, however you want to get to this general form. So what you might want to do is put it in slope point form. So y minus, choose one of the points. So I'm going to choose this one. So y minus 19 equals, the slope is 3 over 2, x minus negative 1. Okay. Then get rid of the brackets. This is like plus 1 there. So that's going to be plus 3 over 2. And we want to get everything on one side and a being positive. So notice how the x value here, the x term I should say, the coefficient is positive. So I'm going to bring everything to the right. So that's going to be 3 over 2x minus y. And then, so really I'm subtracting y from both sides, adding 19 to both sides. Okay, well 19 is 38 over 2. So plus 3 is 38 plus 3 is 41 over 2. Okay, and then I'm going to multiply through by the lowest common denominator. Okay, and there's nothing I can divide out. Normally we like to show all of that on the left, so I'm just going to rewrite it with the 0 on the right. Okay, and then algebraically show that the point 731 lies on this line. So I do a T-chart when I do this, so my left side and my right side of my equation. So I'm going to substitute x and y in to the, so in for x and y in the left side. Okay, so that's going to be 21 minus 62 plus 41 is going to be 0, and the right side is 0. So it works. Left side equals right side. Next one, if the line 3x plus ky minus 16 equals 0 passes through the point 8, negative 2, determine the value of k. So that means we substitute 8 in for x and negative 2 in for y and solve for k. Okay, so negative 2k, that's going to be plus 8 equals 0. So negative 2k equals negative 8, k equals 4. Okay. Point and a line are shown. Draw the line that passes through point A and is perpendicular to the line shown. Okay. What are the slope and y-intercept of the line? So, first of all, we need to know, in order, we can eyeball it, but we want to be exact. So, if I draw a line, it's going to look something like that. Maybe a little rotated. Okay. Something, let me just put that in there. Okay. And so, but we want to be exact. So I can move it, so just do it in pencil. Slope and y-intercept of this line. Well, first of all, what's the slope of the line given? So choose two nice points. Negative 3, 2. So slope of original. I'm going to just fix my pen here. Slope of original equals negative 3 over 2. So slope perpendicular, change the sign and take the reciprocal. So 2 over 3. So let's check it. Did I get 2 over 3 with this? So from this point, I got to go up 2 to the right 3, or down 2 to the left 3. So I'm a little bit off. That's why I said use pencil. So I'm going to take my line here and fix it up a little bit. Okay, there. Okay, so the equation, so we know the slope is, of our new line is 2/3. Okay, and the y-intercept is negative 4. So, again, we're going to end up putting it in this form. So maybe you want to start with point slope form. So we'll have, we're going to use the slope of 2/3, and your point for a y-intercept is 0, negative 4. So we'll have y minus negative 4 equals 2/3 times x minus 0. All right, so if we just get rid of the brackets, we get that, and it says put it in slope y-intercept form, so that's going to be y equals 2/3 x minus 4. All right, then it says examine your equation and your answers in part B. Notice anything. So take a look. Our slope here is the coefficient of x. Our y-intercept is the constant term. So slope y-intercept form, you can actually determine a lot of the times by looking at the graph. Find the slope and the y-intercept and substitute it in. Okay, so coefficient of x is the slope. Constant term is the y-intercept.